Hi there. In this video, I'm going to help some of my students or other people learn how to calculate the molarity or the concentration of a solution in moles per liter. Now, when you see the word molarity to a chemist, that means one special thing. That means it's a concentration, which is how strong a solution is, meaning in terms of how strong, we're talking if you were to take a substance and dissolve it in water, it depends how much substance you put in makes it stronger, or if you made the amount of water that you put it into, that could make it stronger as well. So those are two factors: the volume of the water you're using and the quantity of substance. But this quantity of substance isn't always mass. It is sometimes the number of moles. So when you want to know how strong a solution is, when chemists see molarity, that signifies that they're doing that strength in moles per liter strictly. So the formula you use to get the molarity, you need to, if you look at the units, it tells you, folks, moles per liter, N for moles, divide by the volume in liters. So to calculate it, take the amount of substance in moles, not grams, but moles, and divide it by the volume in liters. Now let's take a look at a couple of examples. If you had 1.25 moles of sodium chloride and dissolve it into 250 mils of water, determine the molarity. Molarity means concentration. That's what we don't know. So we have 1.25 moles. That would be N, 1.25 moles. And our volume is 250 milliliters. Well, this is not what we want. Our directions for molarity say that that should be in liters. So we will divide this by 1,000, and that puts it into liters, 0.250 liters. Now, we can move a couple of these things. Now we have our moles and liters, so we're ready to go. Concentration, N over V. You have 1.25 moles, divide by 0.250 liters. Rather than bring up a calculator, we know if we were to double this, you would get 2.5 moles per 0.5 liters, and doubling it again would give you 5 moles per 1 liter, and that's your answer. Might as well leave the calculators on the desk if you can. So you now could have a different type of example where if you had 12 grams of calcium bromide and you dissolve it in 500 mils of water, determine the molarity. Here they were not very nice because they gave you a mass of solute and not the number of moles. So we have this little trick here that if you do not have moles but instead have mass, you can use this formula to convert from moles to mass and vice versa. So let's write down what we've got and what we want. We have a mass of 12 grams. We know that our volume is 500 mils, which, knowing ahead, we need that in liters, so we'll divide by 1,000 again. So we have 0.5 liters is the volume. We have a mass of 12 grams. We need concentration in moles per liter, so we also need number of moles. Well, to get the number of moles, we know that you can take the mass and divide by the molar mass. Well, the mass is 12 grams. I'm just adding zeros there, sorry. But we don't have the molar mass. So to get the molar mass, we look at what our substance is, calcium bromide. Calcium bromide is a calcium ion, plus 2, bromide ion, minus 1. We need to balance these charges out, so we need 2 bromines. So you have CaBr2. To get its molar mass, you look on the periodic table. So you'd look for your calcium, which is 40.08, and bromine, which is 79.90. And we can then start to work that out. So our calcium was 40.08, and we have 2 bromines, which were 79.90. We'll bring up a calculator for this one, although it can be fun to try and figure around with it. Turn it on. clear our last stuff. 40.08 plus 2 79.90 gives us 199.88. That's grams per mole. So once we have grams per mole in the molar mass, this number can go right into here, the formula that's waiting, 199.88 grams per mole. That is going to leave moles as our answer. So we need to take 12 and divide by that previous answer. 12 divided by the answer gives me 0.0600 moles. And a few zeros. That's the number of moles. Well, now that we have N as 0.06 moles, then we can work out the concentration, the molarity, which is N over V. So we take our 0.0600, divide by our volume of 0.5, and this seems like a fairly easy calculation, but let's take the numbers on our calculator, see if anything magical happens. Divide by 0.5 and gives us 0.12, and those other numbers didn't quite matter out here. So we just have 0.12, 0.12 moles per liter. And we have now calculated the molarity. It's important to remember that your molarity is strictly moles per liter. There are other ways to do concentrations, and in the next few videos I'll talk about parts per million. I'll talk about percent weight to volume as well, other ways of doing it, so you got to keep them straight.